And we are now live. Hello everyone and welcome to today's live stream, which will be a little bit of a redo of yesterday's live stream just due to some audio problems that we had. So this time we should have much better audio balancing between the music and my voice and everything else. But welcome to the stream where I'll be showing off the new geometry node tool features in Blender 4.2. In this case, the mouse raycast. So the Blender devs recently showed off how to make a raycast fire from the mouse position. So this is how it's done. You need to use the mouse position node, as you would expect. Combine them both into a 2D vector, or in this case 3D, but we only use 2 of the dimensions. Divide them by each other, and then multiply add 2 and -1, so that you get a range of 1 to -1, depending on where the mouse is in your window, just like this. And then you need the view transform, the projection and the view, you multiply those together to kind of offset them, you invert it, and then you project the points. I'm still not entirely sure how this works. I think I went over yesterday that the view is like the aspect ratio of the window, but that might be the other one, I forget which. But anyway, so you project the 1 to -1 vector on those matrices, but you add 1 to the bottom one here, so that you can subtract it to get a vector for the ray direction, and of course the top one is the source position, like that. So that simply fires a ray from where your view camera is to the mesh, depending on where the mouse is, just like that. And then this part places a point and instances an object where that raycast hits, instances the object, realizes it afterwards, and sets the rotation to be aligned to the normal, and then it joins it into the mesh. So it's pretty simple. In this case, I've quick favorited it, so you can do that. And after you place it, you can just go and make it scale and do whatever you want. I think I did see a little jump, so let me just see. Oh no, that might have been just a little blip right there. But yeah, after you click, you can then edit the parameters and all that, and it seems really, really cool. I'm very happy that this became a thing, because it could be very useful in the future with like modal operators once they come around. But yeah, I still need to experiment and figure out what else is possible with this. Yesterday we tried like connecting these placement parts with the data from the previous placement. But that was kind of hacky because I stored the previous ray hit on the first vertice of an object, and then I called that next time, which it was hacky, it wasn't great, but it worked. You know, if a hack works, it works. But yeah, that's that. And another thing we tried yesterday, which I will do now, is to instance a cube and then boolean the object based on that cube. So let's do that. Instead of joining the geometry, let's use a mesh boolean. There we go. And now with this, float should be fine. Booleans are very finicky if 2 meshes are on the same plane. So let's try this, and then boom! We can see that that happened and cut that out. But we can also see, since these 2 faces are in the same plane, it just plain old broke, which is very unfortunate. Now, maybe it would be better if I had to operate on every mesh island separately, but let's not worry too much about that. Oh, it just broke even without any colliding meshes. There we go, that's a bit better. I'm not sure why this one's freaking out. Oh, wait, I think I do, actually. So one thing that happens in Blender 4.2 is that when you add an object without a material, it basically creates an empty material right here, an empty material slot at least. Which makes a bit more sense, but makes some previous workarounds for transferring a material from one object to another not viable anymore, which is unfortunate. We really need a sample material node from a mesh, because right now there's not really a way of transferring the material from this object to that one. Well, no, there is a way of doing it, but it won't make it so that it's fully eliminated. Actually, no, I will try that, just to make sure that I'm accurate in my assessment. So set material slot, or material index, which should be that. So if we set that to be there, try that, or wait, no. I'm going to refresh the file and then do that. Okay, so 1 second while I go and refresh the file. Open, don't save. Open. Okay, we're back. So, to make this accurate, let's set the material index. Now, I'm wondering if we do this, it probably won't do anything. Oops, and the quick favoriting just went kaput. Oh wait, that actually worked. I'm genuinely surprised by that, because I thought that operated per mesh rather than per object. Okay. Well then, never mind, we do have a way of doing that. Oh, that's why we test things live. Quick favorites, and then remove the old one from quick favorites. There we go. But it still makes the empty material. That is unfortunate. Why would it still create the empty one? Actually, let me make sure that... Oh, no. It's not actually... Uh-oh. Okay, it just lagged for a bit. Okay, so it's not actually setting the accurate material. So, unfortunately, I was right. Very unfortunate. So how would we do that? How would we make it so that the material actually gets transferred? There will be easier ways in the future, but right now I'm just testing a little bit. Later on in the stream... Okay, so that will set it all to be 1, but that's not that great because it's setting on everything. I could just store a named attribute to assign a value there, or just capture an attribute with a value of 1. But here, we'll do that. Make it a boolean, make it be checked. Do that, and then it should work as intended. There we go. Now I'm going to check and see if it creates that empty material, which I assume it will. Yes, it still does that. A little annoying, but not the end of the world. Just a slight setback. Okay. Very, very interesting. But on the plus side, if I go and do that boolean setup again, so mesh boolean, let's go and connect that into there. Is the audio okay? Just checking in to see that all that is good. It should be good. I did a bit of testing earlier today. Let's set material. Let's make this just white so that we can see if the boolean works the way I expect it to. And I forgot to change that to be a cube. There we go. Let's just put that there and then do that. Huh. Or no, wait. I need to set it to be a different material with a different color. Here, let's go and swap that around. There we go. That's what I meant to do. Okay. So this is still very much in its early stages with tools and all of that. But we're getting there. We're getting the ability to do all kinds of cool stuff, and with modal operators, I think we'll be going crazy with all of that. But it's good that we're getting the basics in, like just mouse position and all that. We still have stuff like the 3D cursor, and coming up soon, we'll be getting the active selection. Hopefully in 4.2, I think that'll make it in. But once that does become a thing, then tools will be in a good position. I was waiting quite a while for the active selection because that was a very requested feature. Because right now, if you wanted to do like a shortest selection path from like here to here, you can't really do it because there's only 2 selections and all that. You could use an accumulate field node to find the indices and then do that. But then when you have multiple selections, it's not that great. And then the order would still be wrong because the indices might be in a different order than your selection order. So active selection will be very useful in the future, and I'm looking forward to that. Okay, I guess we can call this part of the stream done, and now we can move on to the other part, which will be in Blender 4.1, not 4.2. So let me go and open up that section. I've been working on my particle system a bit and editing it so that it works with kind of strings and ropes and stuff like that. Stuff that you would find in, I guess, Houdini or something like that. But in a much slower capacity because, of course, it's geometry nodes. Geometry nodes is not fast in its current state. But here is the current version. It's, you know, kind of as you would expect, just a ton of strings moving around. You can see that the spheres are accurately... Those are its kind of collision points, which I still need to figure out a few things about it. The self-collisions are working, and I made them a bit faster than last time. And then, yeah, there's those collisions. There's the or not the ray length, the segment length that we have working, and so on. Right now, there's only 5 iterations for the collision steps, which we can look inside here. So I changed this a bit since last time. Sorry, just checking the chat real quick. Where instead of having a repeat zone for the substeps inside of each of these collision segments, they're all just the same. Which on one hand makes it a lot simpler, that you just need one repeat zone and then it all just works internally. You just put all the collision steps that you want. But I kind of regret it just a little bit, because sometimes you want more mesh collisions and less self collisions just for speed optimization. But for now, it's okay. I'm okay with it. But yeah, so for today's little project, I want to make it so that instead of this being more like a particle system, it'll be more of, oh, you have a ton of curves moving around and then you apply physics to them. So more like an actual hair system or, you know, something along those lines. It won't be exactly like it, but it should be okay. It should be decent. I cannot make this a hair system just yet because, well, I don't have local rotations and all that with the setup. So there's a lot to figure out if I ever want to try to tackle hair simulations again. But for stuff like this, with little weird creatures moving around and doing all that, you know, it's pretty cool. And also, if I turn off the pinning, it'll look like little worms, which, you know, fairly gross, but okay. Let's go and do that. So there's just a ton of little worms like that. I also keep the scale reference here, which, yeah, that would be a terrifying situation for anyone to be in. So let me just move him over to there, away from that. But then, what I did was make a little noise field right here, so that the creatures can look alive, which is a terrible, terrible idea, and extremely gross. But, you know, all part of testing the physics and such. But, yeah. Okay, let's go and turn on the pinning again, so that looks a little less gross. It's just, you know, just a tangle of strings going to and fro. And it works decent enough. I'm quite happy with the results. It could be better, like the self-collisions are still a little bit finicky. Just because with the way Blender handles, like, nearest indices, you can only get the first nearest index in a way. So here, we can see this is the self-collision setup. I found that capturing the index of nearest beforehand made it a lot faster, which I was a little surprised by. I thought if there was just one node here, it would evaluate only once and it would be good. But I think with the repeat zone, there might be some funky stuff that the devs mentioned, that when things are not captured, sometimes they can get exponentially worse. In one of the kind of bug reports I saw. So I'm just capturing that because it makes it faster. I'm still not entirely sure why, but I have a hint. But yeah, you take the force direction, then you get the length, normalize that, you scale it, and all that good stuff. I made this a while ago, so I don't fully remember all of it, but if it works, it works. And then, yeah, let's explain the rope length. Now this one, we get the index before, like here, this index would be that part, and then the after one would be there. It gets the distance between the two, the vector between the two, and then we edit that so that it tries to go within a certain range of that, and then we average the two by using that. I could have used a mixed node there, but it doesn't really mean too much. Then you pin the end by just making, you know, having the position, and then we turn that into an offset. Because in this scenario, I just hooked it up to the offset. And we could still repeat this as many times as we like. But in my testing, this is also a good point. I was thinking of just making it purely relay integration. So it was only position-based physics. But the problem that I ran into and that I saw online was that friction doesn't really work well, or at least conveniently, with relay integration. So with my mesh collision setup, which, yes, this is complicated, it took quite a while to figure out, but if it works, it works. Where here I'm using the velocity and I'm editing that and then doing the hit normal and all that. Where here the velocity is different than the position offset. The position offset just moves it so that the spheres are not are not going through the object based on their distance. But the actual hit here determines the velocity. So whether it slides across the surface, which I can show this. So friction off, we can see that all the parts are just sliding around, not doing anything, which, you know, looks pretty cool. But friction looks a bit more grounded. Pun intended, I guess. But yeah, you can see that they're actually sticking to the surface and doing their thing. With bounce, if I set that to be 1, and I am expecting that I did mess up a little bit of the physics when I was editing the system to, you know, only use this method, the only one sub-step iterations and all that, but it should be okay. But let's go and edit this so that it is better. So there's a few things that need to be fixed. Like with this system, I made it so that in the particle solver, it would move the particle right here, and then the next step, it would go and basically rewind to the old position and then do the collision step. This is so that if you just turn off collision, it'll still function. So in this case, if there is no collision, the physics is still physicsing. But with that, it's a little less efficient, it's a little bit more expensive, and there's more nodes, which could be more confusing. So that is something with the other version I want to change. Because with this, I don't want it to be... If I'm just making a kind of hair system, I don't want it to be a particle system. I don't want it to have to be so... complex. So that's why I want to simplify the entire setup. So I guess what I could do is make, let's go and just hide almost everything. I just want to keep the colliders and let's make a new collection. I'm going to make a new collection, no, not a new collection, a new object, which will be a ton of curves oriented in a spherical pattern. So let's get a curve line. And then we're going to go and resample the curve and then instance it a ton. So instance on points. Let's go and flip that around. So we need points to instance on, so let's make a few of those. And then I just want random rotation and then maybe random scaling. We'll see. So here, let's use a random value, set it to be a vector, put it in here, set this to be pi and negative pi. Let's just go Control-C, Control-V, Control-C, do. So now, if we take a look at this, hello? Oh, we only have 1 point. Yeah, I should have expected that. So let's do just 20 of those right now, which seems to be good. I could scale them differently, but it'll be fine either way. Let's realize the instances, and now we have our curves. Now I won't be simulating on this object, because, of course, this is in local space. While the simulation I want to be in global space. Which in the particle system that I made before, all of them are in global space by default, so when I make this new simplified system, I will have to compensate for that. But fortunately, with the new nodes that... Oh wait, I'm not in 4.2. Dang it. Yeah, maybe, well... Let's see, 4.2 is like maybe a month or 2 away, so... let's keep it in 4.1 and then I can upgrade it to 4.2. If I want. So, yeah, the realize instances node is smaller. I should have realized that. But okay, let's go and make a plane. Let's go and click new. So this will be our string sim1, v1. Let's do that. So now, let's go and get that collision group. Particle collision? Is that... Yeah, that's the right one. I want to duplicate this so that it's not an asset as well, because I inherited that from the previous one. So this will just be string collision, just like that. So now with the simulation zone, I need to think about a few things to do. So in here, we can remove the old position part, because this is the kind of position applier, for lack of a better term. Which means that we won't be able to disable the collision easily. Or no, we still could. I would just need to have a set position, like a switch node, so that it would be... Here, let's go and put this in. Whoops, switch. There we go. So it's like, hey, collision. That is just true, and then we would just have a set position with the velocity up top if it's false. So still easy to switch up, but just more optimized. And I deleted the most essential part of this, so let's bring that back. Okay. So let's bring our, yeah, actually, what should I call this? String, or just, yeah, string. And this one will be sim. Simple enough. So now that we inherit this, it will be in global space when I make it move around, which actually, let's go and do that really quickly. Let's just go and do a quick keyframe, go into the animation tab, and then go into most of these values, and I forgot about that. Let's fix that. Where we can add in some noise, so in this case we can do that. Change the scale so that it affects it, or yeah, the phase is a bit longer. Change the strength so that moves quite a bit more. See, is that okay? Maybe a bit too much, so let me lower it to be around 8. Let's go and copy that, paste it, change the phase. There we go, that's something. Might be a bit fast, but it should be good enough for our purposes. Let's go and just switch that around. Yeah, that's good enough. Good enough. I probably will add rotation eventually, but for now, it's okay. Let's go back into the geometry nodes, which is in the shading tab, which I still need to learn to put them in the right tabs. It's just more convenient, you know? You know. Okay. Let's go over to here, and then we need to have that as our input for the simulation because we don't want the topology to be changing in this iteration. In newer ones, maybe, we'll see. Okay, so let's put the string collision in there, and then we need to set the velocity with a named attribute node. Change it to be a vector. This will be velocity, because, and I spelled that wrong, velocity. There we go. Yeah, that's spelled right. Because the only one that uses the velocity is this one, because it needs the bounces and all that good stuff, where if it's sliding, if there's friction. Like, if it was just bouncing, I think the relay system would be good enough. Probably. But I want that friction, and that seems to be the best way of doing it. If anyone knows better, please let me know. And also, another weird thing is that I recalculate the velocity after the fact, which is also just a bit odd. Because, wait, that does mean it just resets. So does that mean that... I forgot what I changed because I have like 3 versions of this. But I can go and play around with that once I get the sim up and running. Anyway. Okay, so we have all of that. So the velocity, I want it to be like, oh, there's gravity and all that good stuff. But I also want to make it so that it'll follow its original position, so that there's pinning and all that. And speaking of pinning... because I need to make that work with the length as well. I need to think about that one. Because right now, the pinning is happening and putting it in a different position, which we can see it's working right now. I think. Where... is it colliding? It's not colliding. Interesting. Or is it? Oh, the particles have the... it has no size parameter. So there's a few parameters that need to be assigned because of the way I set this up. So if I set there to be a size, this means that it will go and collide. And as we can see, it is working properly already. But I want to make it so that it'll follow its original position rather than just the, you know, the one that's assigned in that one part. So if I do this, it will start freaking out big time. But, that'll be fine. So, sample index. I want to sample the position because that's all that's needed at the moment. So, wait, position, not project. Position and the index. So, with this, if I just subtract from there, that should mean that we get the offset or the quote-unquote velocity. The change in position between the target and the original. So here we can see it is trying to get there, but the pinning is saying, wait, no, you have to be over at that empty that's inside the node group. So that's something that I need to consider. Because here, if I just do this and avoid that, we can see that's trying to stay there, but there's a few issues. One of which I believe is the self-collision. Or just, no, I think the length is bigger than it is by default, so let me go and reduce that. Be 0.1, yeah. Self-collisions will be having a few issues, but we can see that it's at least trying to work. At least trying. But it's not overriding, which is interesting. That is something that I need to consider. Because right now it's trying it on everything. Maybe I need to assign a pin position. Yeah, no, that's probably better. Having a pin position attribute, and then having the pin just be the last point in the chain. Which it will conflict with all of these parts, but it's probably fine. Like, the rope length, like the self-collision should happen first, and then the rope length should happen second, and then that should happen third, because you can sacrifice the self-collisions first. I want the rope length to be sacrificed second, and if there is an issue with the collisions, and then I want the mesh collision to be the last thing that breaks, if a break occurs. And if you're wondering why it's freaking out like that, that's just because I'm adding, instead of mixing between the previous velocity and the new one, I'm adding to it, which is something I should have considered. So if I had just set it to be like that, we should see that it's pretty stable. I'm still concerned about a few things like the like that, because collisions are doing their thing and all that, so I probably will still need a pinning attribute so that I can ignore everything else. But let's just go and do this for now, where, oh, and it's inverted, of course. Okay, so let's use a, multiply add node, multiply add, to invert this gradient, which I could have just switched around to mix things, but I like when the orders are as you would expect. So here we now have the curves doing their thing. I could set this to be the power of 2 or 0.5, I forget which are needed in this case, because I want a better fall off with the mixing. So if it's 2, we can see that that's a bit better. Okay, so now it's basically up and running. I can go and hide the original object, and we can see that it is functioning as intended. I do need to store an attribute for the lengths of all that, for all the segment lengths. But that should be fine. Should be fine. Like, just beforehand, I would need to store the actual length between all the segments. But since that goes 2 ways, how would that function correctly? Would that mean I need to store two of those? Because that would not be fun. Because the difference between this and the previous versions of strings that I've had is either using the blur attribute node, which won't work because setting the length is not as straightforward, or it's not as good. Actually, could I make it so that it would work? Just blurring the position and then saying no, but that would mean it would be even on both sides. If all the points were equidistant, it would be much easier. But the kind of plan with this is so that you can throw any kind of curves at it and it'll do what it's supposed to. Let's go and add in some more strings, because that could be fun. Because right now we only have 20. Let's go and bump it up to 50. You can see that, yep, it is functioning as intended. Now, I could make these different lengths just by, oh wait, I forgot about that. We can go and resample it after the fact, so that we can have a different amount of points on every single one. So, random value, let's go and set that to be between 10 and 20. Let's go and just edit that. So here we should see when the simulation is going. I hope it's okay on stream. I know the bitrate can be a little not great with a ton of thin lines like this, but maybe the orange helps. So here we can see that it is functioning as you would expect. What else is happening? Because it still feels like something's off. Maybe the lack of gravity. Yes, that is something that I should have added before, but let's not get too ahead of ourselves. Let's go and put in some frames. So this is, I guess, pin, yeah, pin position, and the shift key is a little bit stuck. There we go. There's that. There's, I guess, pin, actually, pin fall off. Yeah, that's good enough. Let's just go and collapse this so that's a lot smaller, and it should be good. Control J, there we go, and then that's just pin. Okay. Actually, oh no, wait. I can actually get rid of that, and then we just swap the parts here so that we have the velocity on the bottom. That's better. I think that is quite a bit better. I'm going to edit the stream title because we're off of the node tools part. And now Blender 4.1 physics. Node physics. Yes, let's go and do that. Save. Just keeping it up to date. Okay, so now that we have this, I could still have that there, and that's good. But that just means that we can add in the other nodes easier. So let's have the gravity be 0.1. If you're wondering, oh, why aren't you using delta time? That's just because I find using velocity easier when experimenting. Like, I could implement it so that delta time does just work, but for the moment, just the actual distance between each frame is easier for me to understand. And at the moment, well, I'm not going to be changing frame rate. 24 frames per second is good enough, because that's what the movies use. In most scenarios. It's interesting. I'm assuming self-collisions are having a field day with how far apart they are from each other. Which, speaking of that, let's go and instance on points using the size to determine that so that we can actually see the stuff that we need. So named attribute, let's go size, put that into scale. So here we can see the actual size of the thing. And that should be working. Unless I'm mistaken. Yeah, let's go and change the size to be even smaller. So that should be good. There we go, that's a bit better. But we can see that some... Oh, the friction is making it so that it tries to stay together. But yeah, that seems good enough to me. So this is just strings. How are you doing the mesh collision raycasting? Well, that's the thing, I am not raycasting. That is continuous collision, which I have used in the past for particles with a size of 0. Which I've made a system that works okay, the only caveat being when there is a collision, it acts as if two time steps have happened at the same time, which isn't the best. But it's the only way that I found that makes the sliding and the friction and all that work as intended. In this case, I'm using a mixture between Verlet physics with impulse preservation, like something close, semi-close to that. Here's the setup. So, Verlet physics is mostly just, oh, your old position and your new position, but in this case, I'm keeping the impulses or the velocities together. This is just stuff I've learned from previous papers. So in this case, this is complicated, but I can explain. So let me hide the timing so that we can see everything a bit better. Come on, work with me. There we go. So we have the collision mesh, we realize the instances, all that good stuff. And then we get the proximity to the mesh. This determines, oh, will a collision happen? So in this case, we take the size, I add in a maximum. I think that's just error handling, just in case, float point precision errors and all that. But you have that, and then you subtract the distance to get the hit distance. If the hit distance is less than 1, then a hit occurred. You go and store that. If you're wondering why I store it and then store it again, that's because with the substepping, if it hits once, I want it to be preserved later on. It's just what I've had to do. But after that, we say, oh, if it's hit this iteration, this one has a hit on any of the previous iterations and all that. It just says, hey, if there's a hit, label as hit. If there wasn't a hit, then just continue with the data that you had previously. But this is, did it hit this time? If so, you go and get the hit normal, which in this case I sampled the face because apparently that should be more efficient, but I'm still not sure if that's faster than just sampling nearest surface and all that good stuff. But anyway, let's go over to here. So afterwards, this is where the magic happens, which I still need to try out a few things. So, and this is a modified version. I probably did break a few things, because here, if we take a look, oh no, that makes it so that the friction is gone. So yeah, that's still used, which I'm still a little bit confused by, because the velocity gets recalculated anyway. But no, the substeps and all that, yeah, no, that makes sense. Yeah. Okay. Anyway, so we set the velocity there, and then we actually do the size offset. So if this was disabled, all the parts would just phase through, as we can see here. But since it's there, it basically says, hey, the hit distance, which in this case is in the negative if there is a collision. If it's there, multiply by -1, and then scale the hit normal by that so that the sphere moves far enough away. As we can see here, it works beautifully. So great. But that's how I've done collisions so far. And this is inside of the substepping method that I have, which is, well, first you store the old position for the position recalculation. So you have the velocity, and then you iterate over that velocity, offsetting it again and again and again, divided by the time steps. I guess I could just go and vector map divide, which I actually don't know why I did that specifically. I was probably testing with something else, but anyway, less nodes, better. So there we go. I'm still working on all of this, but this is what I have found. So you take the velocity, divide it by the iterations, which you could also do the delta time. You just divide and divide. So velocity and all that is, you know, I'm currently using just the actual velocity, not taking into account delta time, but it could be implemented rather easily. Okay, so I could just do that, and that would work okay. So that is the sub-steps. And I still really want to implement that for each and every one of these, but it's easier just to have it once, and then just have multiple iterations. Then afterwards, since some of the positions do stuff, some of the positions get offset without recalculating the velocity, I just do a velocity recalculation after the fact. Which, if I were to disable this, we would see that it doesn't quite look right. But the friction and all that works as intended. Actually, if there is a hit, maybe I should make it so that the velocity does not get recalculated. Maybe that would be more accurate. Let's give that a go. There is not a hit. Then you do that, because that assumes that the velocity got recalculated anyway. I mean, it's trying. Then with that disabled, does it look the same? That is the question. Because I do really, really want... And I could recalculate the velocity before there, so that's even more accurate. Let me try that as well. So after those steps happen, velocity gets recalculated. Let's see if that makes it... No, that makes it worse. Okay. Or maybe I need to multiply that by the time step amount. Which in this case I believe is 10. Okay, that's not working at all. Yep, no, it is not working. Okay. Don't you wish collisions were easier? I really wish, it worked. I'm guessing there's no bouncing. No, there should be bouncing. I just turned it off. So here there's bouncing, but no. None of that. Which these are still very much pinned to the surface. If you look at the particle system that I have up on my Gumroad page, it's basically the older but more stable version of this, where bouncing and friction all work almost exactly as intended. And it also has the raycast method, so if you are interested in particle collisions and all that, I would recommend picking that up. It's free, which I should mention. Here we go. So let me go and edit the pin part. Probably should go and break this out of the node group. And then just have one mega group. Because that's the thing that I need to get used to. Making things where you just plug it in and it just works. You don't need to worry about it at all. Again, the goal of geometry node assets are so that the user never has to look inside the node tree. Which I tried doing with that particle system and it worked out pretty well, but I want to make it better. I just wish that just position-based physics could handle the friction and all that, because that would have been so much better. Probably wouldn't have worked with raycasts, because with raycasts and all that, you know, maybe it could have. Because the question is, like with physics with velocity, if, say, there is a point here that's moving, and then it hits there, and then hits there in one time step, so it goes there, there, then there, how do you make sure that the velocity, like when you recalculate the velocity, it knows that it hit there and then bounced out? So, like, in the time steps, you could recalculate the velocity every single time, and then maybe the bouncing would work as intended, but still feels like, I don't know, maybe, I feel like I tried that yesterday, but I'm not sure. So here it would be like, okay, velocity's there, but multiplied by the time step, it would go further. But then next time step, it goes further, 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 and then when a collision happens, it's like, okay, I would have gone that way, but then when the vector reflect happens, it goes up like that, or if the slide happens, I go like that. And then it keeps doing that, which could work. And if it did work, I would be very happy. But I think I tried that. I'm not entirely sure. I do have a version of this that I did try that on, but we need to check that out. Collisions are the most annoying thing in physics as a whole. Like, there is spatial hashing that I need to try out, where it's basically subdividing the space into grid parts, and then you just iterate on all the parts that are inside grid cells so that the collisions work better, rather than having to use the index of nearest, which can only do one. You sample all of them and do a very efficient grid-based calculation for self-collisions. Which is how in the movie Brave by Pixar, they did the hair collisions. So that's stuff that I need to figure out, and I've tried different methods for it, but I still need to do that a bit better. Okay, I think you could use the reflect vector math for that. Yeah, that's what I'm doing for the bounce. It's just a matter of recalculating the velocity that is a issue for my brain. And something that I need to figure out. But it should be okay. Because, yeah. There's also the matter of, if I do use delta time. Actually, yeah, that's a good thing to think about. If I do use delta time in the whole simulation, then maybe the sub-stepping could be a lot easier. Because rather than, that's actually interesting, I need to think about that. Rather than just having an iteration step, which this is kind of doing a kind of delta time, it's dividing the velocity by the iteration, so in this case, it's like, oh, the velocity is actually much smaller in this time step, and all that good stuff, because it's going through 10 time frames at once, time steps and all that. But if I just use delta time and all that, that maybe could simplify the process so that no matter what I do, I can change the time step per, like, area and it would work better. Who knows? But it could make it better. I yearn for only having, like, velocities are easier for my brain to deal with because it's like, oh, this is just where it moved. It's good. But the thing is, you can't only rely on that. Like, where the positions are, that would be much better. Because in this case, doing a velocity recalculation after the fact, it works in this case, which is why I'm still using it. If it's not broken, don't fix it. But the thing is, I will have to fix it. Because I need to recalculate the accurate velocity every single time step. Which actually, I can go and try that. Which this will most likely break stuff. But we will probably need the, instead of just the position old being in there, I want the position old from this. Yeah, that may work. So now the velocity recalculation is in, dang it. Oh, right, and then I need to scale it by the amount of time steps. So, that's actually working okay. Who would have thought? Wait, why didn't I do that before? Now, is this should be more accurate. A lot more accurate if I have everything planned. There we go. And also, I need to join the curves into the mix so that I can see the parts a bit better. So right here, we can do that. There we go. Now we should be able to see the connections. Actually, let me turn down the amount of strings to 10 so that I can actually see what's going on. Then turn up the amount of points on there so I can also see what's going on. So here, as we can see, it seems to be working decently enough. Let me go over to this part right here, and then I'll just have the pin be on the endpoint selection. There we go. So now, wait a second. Why is it not working? I am confused. Oh, no, wait, that's why. I keep forgetting that I keep changing it up. So that seems to work very, very well. Now, if only I can change the collision system to only use the position and still have friction working, because as we can see here, friction does not seem to be working. Let me go and check. Ah, that's why. So here we can see, is friction functioning? It actually does not look like it. Nope, friction is just not working. Dang it. Now, people have looked at ways of doing this, but apparently it's much more difficult to make that work the way that you want it to. So let me also, oops, just copy that, put it over to here. Also, another thing I need to think about is applying, because it seems like gravity might not be working as I intend. It might just be working on only one of the time steps at a time. So I probably need to add to the velocity inside of the time steps as well. But I need to think about that, because we're getting closer and closer to a purely position-based method. But internally, inside of at least this one, it does use the actual velocity. But I need to think about all that. So if we do that thing again, where if there is a hit, which let me go and put that as an output. If there is no hit, then don't reset the velocity. So here, we should see that now friction should be functioning again. And it looks pretty solid in my eyes. So the only recalculation happens after that. Which maybe I should do another recalculation beforehand, because of all that, which maybe could make it more accurate. But yeah, interesting stuff that I want to figure out. Because I could just go and put this inside of the node group and call it a day. Might be better. Might be. Just something that I need to think about. Because again, I want to not use velocity, but it seems like I need to use velocity. Based on everything that I've seen. Based on everything that I've seen. Let's see. Hi, this is a bit unrelated to your project, but I saw your threaded rope livestream, and how do you get the square fraction texture at the beginning? Oh, this? Are you meaning this texture, the kind of grid at the bottom here? If so, that is fairly, well, semi-simple to do. I just made a node group for it. Let's see. So we have, like, and also the velocity is useful for just storing the forces that you want on there. But I could just say, hey, that's something I need to think about. Because now I'm thinking, okay, I just need to put, which would be more convenient for me to just, yeah, no, that would be better, wouldn't it? Just to have a delta time thing. Just to have delta time, and also delta time plus the substeps. Like, just making all those into one, then have a simulation zone and a repeat zone all in the same thing, and then call it a day. That could be good. Why is the position-based approach preferable over velocity? I'm not sure if it's necessarily better, but it is just simpler for me to deal with. Because if you have to worry about recalculating the velocity or moving the position and all that, it can be a bit annoying. Like here, I'm offsetting the position because that's easier to deal with. But I could just say, hey, instead of actually offsetting the position, you offset the velocity. And then you just calculate all that after the fact. Let's see. Square fraction texture. Yeah, I'm not entirely sure what you're referring to. It was from a different tutorial a while back. You used a vector math, but then I can't see the effect on the model. Did you use a custom UV map? I'm not sure which project you're referring to, but if it uses vector math, it's probably something simple like a fraction. Oh wait, do you mean... Here, let me just see if I know what you mean. Let's go over to here. Quick side tangent. So there's a UV map and then fraction. So there's a vector math fraction node right here. And then you can scale it and then get the sections like that. Is that what you're referring to? Then with that, you can go and use a floor node to get the actual segments and then white noise and all that. Oh, that, yeah. No worries. So here you can get all of that data. So fraction, you can floor it as well and then get random noise per one. Just be aware that if it's a 3D kind of thing, in this case I'm using the UV map, but if you use the geometry position, it could lead to float point precision errors if if it's at 0, 0, which in this case I think I moved the plane. Actually, no, I didn't. Maybe it's the actual object that's raised a bit. But you can see it flips from there to there just a little bit. But yeah. What's that plugged into? Oh, that's plugged into the, just this surface, but you can plug it into a mission thing or whatever you want. In this case, it's just plugged into surface output, which converts it into basically emission 1. So just like that if you want. But yeah, fun stuff. like the fraction and floor nodes and white noise, these are like your bread and butter when dealing with some node texture effects. They're very, very useful. Very useful. Okay. I'm super new to nodes. I really appreciate the knowledge. I'm happy. Like, nodes are very... They're good for learning stuff like vector math and all of that, because you can see what's happening very quickly. While with code, the iteration time is a lot longer. It seems like all this is working much better than before. Like, the friction seems to be working a bit better. Now, the friction can still be a little bit iffy because the friction and the length are both fighting each other. Which, if something has a friction of 1, you would expect it to stick there no matter what, but in this case, it's not. And that's because, well, parts are actually getting pulled. But as we can see, this does seem to be the most stable version of the effect so far. And I want to keep it that way. At least as much as I can. But yeah, this seems extremely stable. Let's make it unstable. So in this case, there's only one step, which means that stuff will be falling through the floor. It just moves too fast for the radius. If we do 2, we can see that it's a little bit better. So with Blender's rigid body system, if I remember correctly, it goes with 10 steps and 10 sub-steps or something along those lines. I forget what each of those are for. But that's what I kind of have as a base, just 10. And if you need more, you need more. But for the time being, it seems like, you know, it works pretty much perfectly. But it seems to be good. The downside is, this method will not work with particles with small sizes. Because you would need continuous collision for that. And that's uses raycast and all that, which is even more annoying to work with. In the terms of, like, collision, reflection, and all that. Oh, that's funny, just seeing that one spin around. That's really cool. I probably should assign a different color per spline, so let me go and do that. Let's just go, spline, this be random, and then have this be a random value as the name implies. So we have that. See, we're almost at an hour. I think I could go for a bit longer. This stream is going quite well. Better than I was expecting. Or playing around with physics, because me and physics have a complicated relationship where it takes up a lot of my time and I just get frustrated. But now that I'm getting a better handle of, oh, okay, this is how it should be done. Like, with trying to simplify it so that velocity is used less and less, and just the position is used because, you know, positions are more basic. They're like, okay, this is where you were, this is where you are, then you just do what you must. That means that stacking different types of collision, like self-collisions, and constraints and all that, are easier to work with. So, a only velocity method, which it is good with continuous collision using raycasts. It's here, let me just say, material 02, are you being used for anything specific? Actually, wait. Oh, right. Yeah, I could just use the old shader for that. S random, does that, yeah, there we go, okay. So now we can see a random color per one of those. There we go. That just makes it a little easier to see. I could use a curve to mesh node and set the material, which could be good. So that we can actually see the connections in the rendered view. So yeah, let's, yeah, curve to mesh. That's what I was looking for. Okay, and we can just, no, I need to set that in post. Profile curve. This is getting a bit big, but if I make this work correctly, I can compress it into a node group and then never have to look at it again. That is not a real error. Just whenever you have an object input, it says, oh wait, no, I'm being fed a mesh, when in reality, it's not. Actually, if I separate components, let's go and do that. Does that fix it? It does, okay. I need to remember that. It makes complete sense, but that little error message shouldn't really be there to begin with, but I guess, yeah, well, I guess it could be useful. I guess it just evaluates it differently, because there should be no curves here, because right now it's points and splines. Maybe it reads the points as something different. Who knows? But here we can see the tubes and all their tubes be tubing. And there we go. And we can still see the spheres, but let me just divide the radius by a bit so that we can see the spheres a bit better. There we go. Yeah, that's good, so that we can see everything as it should be. And let's go and put these into frames. Like, I don't like how big this section is for a simple operation, but I don't really see a way of making it any better. There we go. So let's just go and compress all of that. But this is fun. This is, like as I said before, collisions have been very frustrating for me because it's a lot of complicated math and especially trying to convert code into nodes. But we're getting there. We're getting there and it's working quite well. I just want to make it so that this does not use velocity at all. But I'm still not sure if that's even possible at this time. Because, yeah, still need to think about that. Like, this solution is not bad. It seems rather stable. Friction seems to be more frictiony than before, and all that good stuff. And for the forces, I still need to think more about that. Let's see. Do you know how to make light trails on a curve to animate it from one point to another? I do have a system for that up on Gumroad, which uses curves and then it makes a trail from one curve to another. It is a little more involved of a process than I would like, just because you need to use simulation nodes and all that. But yeah, I would recommend looking on my Gumroad page for the trail modifier. It's also free. Most of my like tech demos are free, but the actual like products are usually paid. Just because with stuff like this, like the particle system that kind of uses similar tech to this is free. Like look, all the friction system is working beautifully. Look at that. Even when the surface is almost vertical, the friction is working almost perfectly. It just kind of bounces off a little bit, I'm guessing because of the length and all that. So, I am improving the collision system, which is good. I'm liking that. The more I improve the collision system, the better it will be in the future. I'm not sure you can get rid of velocity entirely if you're doing collisions. That's what I fear. Oh, and I'm only using 5 substeps this time? Wait, what? Only 5 substeps and it's that good? Really? I'm surprised. Very surprised. That's really good. Wow. The only downside I can see is that the velocity is not quite doing what it should. Because the velocity gets recalculated, I'm assuming that the gravity only gets reapplied once every step. So here, I could just make the forces, like I could just label this force. So force. I have a bad habit of having dyslexic typing. Maybe, yeah, it's my keyboard. It's not me, it's my keyboard. Need to get a new keyboard. It's a membrane, so it's not good. I have friends telling me that I should get mechanical keyboards, which I have used them before. They are good. I just need to find ones that are silent because, uh-oh, what did I do? So, actually, wait, the force, we don't want the previous velocity to be into there. So there, oh, the gravity is much more apparent and much more influential than it should be. So maybe it was better to just have it the way it was before. Maybe. It's freaking out, I'm assuming, because of self-collisions and all that. Like, everything just being way too aggressive. Maybe. Maybe. Yeah, let's switch it back to velocity. Because, yeah. Because the substeps are only for the collision pass. I don't know. Like, this is the most stable I've ever had my collision system. Like, stuff like that just would not function the way you would expect. And it seems like gravity is working as intended, because even when it's on a slope, even with it on a slope, it seems to be working. No, it seems to be working perfectly. It seems to be working perfectly. Like, it goes down. Like, one problem that I had in previous versions was when it was on a slope, it wouldn't fall down correctly. Let me change friction to 0 and then have bounces. Because one thing I do want to try is... Let's turn off the rope constraints, and then also just not view that part. Let's have it so that those just bounce. Bounces seem to be working well. I'm not seeing any obvious, Oh, well, there does seem to be a slight decrease in power. Actually, no, it seems to be accurate. So bouncing is still working pretty much as intended, and any slight deviation in power could just be from the pinning. As we can see, actually, wait a minute. Why is that looking weird? Self-collisions look like they're screwing up just a bit. Just a bit. Yeah. Well, I can deal with that. Okay, let's re-enable that. So, this version seems to be almost perfect. Let's go and turn it back on. And again, having this, it doesn't solve everything because it's still... It's stepped, which is more accurate, but if the particles have a size of 0, then they won't do their thing. Which I would like it so that they could have a size of 0 and still function. But that would mean that I would need to switch to another system. And also, another problem with this is that the segments do not collide, only the points between the segments. Which I've tried to figure out collisions with all that, but unfortunately, that has been difficult to figure out. Line-to-line collisions, rather than just point-to-point. This point-to-point is simple, but interpolating between that is another kind of continuous collision, I guess. It is very difficult to figure out that properly. Let's see, we're at 1 hour and 8 minutes, which is good time for stuff like this. Like, I have what I want. A physics system that has points, has pinning and all that, and it works as intended. Let me turn the friction up again, because, you know. There we go. Strings and all that. Or wait a second. Oh, the bounce is making it so that the friction is not being properly cared for. I carry the parts just fall, and they look really heavy because they're, you know, they don't bounce and they have friction, which is good. I set the bounce to 0.1, then that means we should have just a little bit of bounce, but then they still hit, and all that's good. Which means this could be a chain system, which could be pretty cool. This could be chains, not change, or yeah, that works too. It works well, which is what I'm happy about. Yeah. Particle self-collisions, I still need to figure out. Yeah, how about let's try just one really long chain. So only one of those, but we make it like 1,000. I really wonder if this is slower. Oh, dang. 1,000 points and it's slowing down. That's sad. That's sad. It's only at 10 steps, right? So, I guess internally, yeah. Like, it seems mostly stable. But then again, it is falling through the gaps between itself, which is just a fault of the distance. Then when something happens, it seems to have a ripple effect, which is really funny. But it seems mostly stable, which mostly I'm good with. Let's go and change the segment length because I want it to be just about... Oh yeah, 0.3, yeah, that explains a good amount of that. But we can see here... No, it seems to be working. Okay. They seem to be falling over each other and not freaking out too much. Actually, no, that's really stable. The only freaking out is with the curve, or the curve normal acting a little bit weird. So if I just turn that up, that should be very, like, barely apparent. So we have all that. Falls to the ground, and as we can see, looks pretty good. The only thing that's not quite that good is that there's no velocity sharing between all of the parts. So wait, now what part is being pinned? Because the pinning isn't... Is the pinning only on the end? Yeah, it is. Okay. But where is the end that is actually being pinned? Like, that part's not. And we can see that the physics are working quite well, I think. Like, it even whipped. That's interesting. We have that, and then it whips around. I still have a feeling that the forces, like the gravity, isn't nearly as good as it should be. But seeing the whip happen, that's a good sign. That is a good sign. Oh, I found a fantasy portal on your page. It seems like Aiden used them in a certain visual thing. I'm not familiar with that creator, but that's very interesting. Yeah, my work has been used in many different media productions, and it's always cool seeing when it pops up. Because sometimes I'll just be looking around the space, and I'm like, hey, there's that thing that I made. And I'm very happy, because quite a few of those projects, like even physics, with physics projects like these is the biggest part. It's like, okay, I put a lot of time into figuring out, oh, how does this work? How does that work? And seeing it actually be useful for people is very nice. I think one reason that this looks a little bit weird is that, well, on one hand, like the particles whipping about, since this mesh is very thin, it kind of, when it's underneath, it goes around, and then when it comes up, it's like, oh wait, I should be on that side, and then it just pops up. So if I were to give this a little bit of thickness, there we go. Oh, wait, whoa. Oh, no, that's because the normals were inverted. That's why. Now we should see that, there we go, it's very solid. Chain is doing its thing, and it's doing all that. Still feel like the force is not quite as it should be, but look at that, that's pretty solid. It's just a shame that I can only use 1,000 particles before it starts freaking out. Speaking of freaking out, what is going... Well, okay, yeah, that's another example of, since it has no thickness, it is freaking out. Let's go and recalculate normals. And also, yeah, let's turn off the bevel. And then shade smooth my angle. Yeah, that's good enough for me. There we go. So now we have that, and it seems like that's working a lot better. No severe jittering. Like, there's a little bit, but again, these are only referencing one of their neighbors, which will always cause jittering, so I do need to figure out spatial hashing. Let's read the comments, bro. If I'm right, Aiden used your product. That's crazy because he has 700,000 views on the video. That's very cool. Yeah. Very, very cool. It's always nice seeing my work being used, my products being used in other productions. Let's see, okay, now that that's like that, it seems like I want to try this out with other, because The friction is very solid, and I'm very happy about that. But let's try it with a variable size, because I kind of want to try breaking this at this point. I want to see parts where it's just like, oh, I'm moving when I really shouldn't. But here, it seems to be so incredibly solid. Which is weird, because this was almost, not entirely by accident, but I did not expect it to work. And here, I'm wondering why, like, that's the pin part. So I'm assuming that's freaking out because I do not have the pinning integrated properly into the rope length constraint. Like, I do have a part, but, yeah. So that's one thing that could be a little bit iffy. And is a little bit iffy, but I'm not too concerned about it. Okay, that's good enough for me. And if let's see what happens if I have the velocity recalculate every single time. Like here we can see, yeah, okay. The, friction is just not really a thing at this point. But it's so cool seeing, like, when it is fighting, even with that many length parts to it, it's still working. Like, as far as I can see, the lengths seem to be consistent. Like, they're not quite as jello as I would expect. Let's turn friction up to 1 and see if it actually does anything. It does seem like it's affecting it a little bit, but not as much as it should be. But there it's just solid. It's perfect. It's absolutely perfect. Okay, maybe not absolutely, but it's good enough. Okay. So the question is, to make this even more stable, do I change this velocity to be the velocity that's just gotten from the rope length and all that? So basically, taking this and then putting it in there, which, let me just do a quick check. 10 iterations. So instead of using the velocity, we calculate the said velocity on the fly. So there, let's put that there and there. Let's take a look. Does this make it better or worse? I mean, it seems good to me. I'm not really seeing anything that could be breaking at this point. But we'll need to try it with different things, like, is bounce working exactly as it should? It looks like it, but let me turn off the length and see. Oh my god. Let's turn off self-collisions as well. That we can just have that and then have it bouncing. And then we can see if any energy is being lost. I don't know. That seems to be working. Or, wait, something's off. So it goes up once. And then down. And then, oh, I've had this issue before. Where it goes through weird phases like this, where it's like, hey, I'm doing this, then I'm doing that, then I'm doing this. Let's use the velocity in here again, see what happens. So we have that, then it goes up. Or no, wait, the same thing's happening either way. So that may be a problem in the physics system. Or no, is it even? No, it might... Actually, might not be wrong. Let's see. Maybe I'm just looking at it wrong? Like, that kind of pattern where it's like, oh, up, down, and all that should be fine. Well, okay, at the very least, the velocity recalculation should be fine either way. And in theory should be more accurate because it will take into account the self-collisions and such. So if I turn on self-collisions again, this will explode. Simply because when it spawns in, it's just way too close together. So let me go and turn off the curve rendering. So here we can see, yeah, that... I mean, it seems to work. Let me try turning bounce to 0 and friction to 0 and see what happens. I mean, that seems to work. They're traveling, they're doing their thing perfectly. Yep. Friction 1. Let's try that. Oh, that's beautiful. Okay. So it's not 100% perfect. There's still a little bit of error, which I'm going to assume is just... Look at that. I'm assuming one just hit another part and then it just went down. But it seems like there's still a little bit of friction issues. Like, it's not completely stuck. But it's close enough to where I'm happy with it. Like, those things were moving fast, and then they did that. And then they hit their neighbor, which, oh, that reminds me of another thing. These will just bounce off each other. There, it hit the neighbor and then went off like that, which is, it's cool to seeing it working so well. It's so stable. Like, it is falling just a little bit. But it's not that bad. Yeah. I wish I could simplify this, but... It seems like this is really the only... Oh, the music got a bit louder. Let me go and lower that by a bit. There we go. Yeah, okay. Is the music too loud now? Because it might be a little bit louder, so let me lower it to... There we go. It should be in 35... Yeah, no, that's better. Okay. I was like, why did that particle fly? But that's the pinned particle, so that should be fine. And then if we turn off self-collisions and turn on just the chain length, we can see that, yep, it's working pretty much perfectly, but it phases into itself as you would expect. And then when I turn that back on, we can see that it just does not collide. That looks good. So, lesson learned, we can just use regular old velocity for that, and it seems to work very well. And then just get stored. So I guess the question is, how do we make this even better? Because we have the position offset and the velocity, how do we make it so that it just works? Because the velocity would just affect it in the next frame. One thing I could do is just, instead of actually storing the velocity there, I could just have a velocity output, and then... No, but this is simpler. So this is... hit. Here we go. So, yeah, that's not bad. I would just need I wish we had kind of global attributes for the time steps. Because right now, yeah, there's no time step involved with this, so that part's fine. No velocity in there, so that's fine as well. Like, that's the good part. The only part that actively needs a time step is velocity. If not, it would just work perfectly no matter what I throw at it. It's like, boom. But yes, I will save this really quickly as the best version so far. Save as... Yeah, this is fun. I could go for a little bit longer. I'm not quite sure what else I could do. Because right now, we eliminated the velocity reference, which is good. But I need to take into account essentially the delta time for that, which could be just a little bit of an issue. Right, like right now that's the quote-unquote delta time. Yeah. Position old and that. Yeah, let's just do that. Let's update this to use kind of a delta time. So this will be delta V for well, yeah, delta time. And of course I mixed that up. So in theory, that's kind of a delta time. Or no, wait, that's how many time steps happen in, which if I remember correctly, delta time, let's go back to the simulation zone. That is a, here, let's just plug you into there so that you're evaluated. Oh, come on, come with here. Okay, so here, yeah, that's a divider, so I would have to divide by the delta time. So iterations would be, yeah. Okay, yeah, delta time I would have to edit a little. That's time steps. Let me just label it time steps just for simplicity's sake. So how many time steps happen? 10. I'm leaving it as a float instead of an integer, so that when I do update it, it'll be simpler. So with the delta time, I would just divide the delta time by 10, and then that would be the new delta time, and then I just feed that into all of this. I don't want to store it as a named attribute, but I also don't want to have a necessary spaghetti line going through every single part of this that needs delta time. That's annoying. But I think it may be necessary. Yeah. Well, that's something for another time. Something for another time. And then I could just put iterations into time steps. Now, if I set this to be 5, it should give a pretty close to accurate result. So if I were to make this like 80, which this will... Oh, why is it so slow? Other programs get away with much more. But it's just the... If we look at timings, it's because of the collisions. Because again, collisions are the most potent thing. Like, if we take that times 80, even that's super expensive. The most expensive one being this. So times that by 80, you get something very, very expensive. Okay. I still feel like we could do more, but I don't know what. I'm still ever so slightly concerned about the actual velocity part. Because here, I should be able to just... Here, let's try that. Let's just have another input as the kind of force, kind of like what I had before. So there we have a vector input. Then we should be able to divide both of those by delta time, and it should be good. So here, if we just have just gravity, let's only have gravity as an input here. And turn down the time steps so that it is interactive. Here we can see that for some reason that is much more than it should be. Because it's being iterated on every single frame, but that makes sense. Like, it should make sense. I'm slightly confused. Is this a delta time thing? I'm not sure. How long have you done Blender for? I think around 8 years now. Probably around that. Ooh, 0 gravity string. That's amazing. It knotted itself. Or wait, is it actually knotted, or is that just the self-collisions bugging out? Well, there's one way to find out, which is to actually render the, a knot! There's an actual knot! Well, I guess that's a success. If your physics system has knots in it, then that's pretty good, isn't it? That's some good stuff, and at 10 steps, well, yeah, that should be good. Look at that. This is the best version so far. Yeah. And that's a small knot, too. Now, that will 100% phase through each other if I put strain on it without enough time steps. That's some good stuff. I feel like I'm actually... see the knot in slow motion. Well, I assume that the knot gets created because everything spawns in like that. So it looks like that. One time step later, it's not colliding, which I'm very impressed by. Like, look at that. Oh, well, they're slightly colliding there. But with enough of that, that happens, and then we get something like that. So there, that is beautiful. Okay, I'm going to... We still have the force there, which gets put into there. Do I need to divide that by the iteration count before then in order to make it function as I wanted? So I divide it and then divide it again. We'll see. That looks like it's working. But why would I have to divide it twice? Also, it seems like it may have gotten worse, but I'm expecting that to be a repeat zone issue. So storing it as a named attribute would probably be better. Yeah, look at that. This should be the best version of it, where it is fairly stable. Like, there's a bit of jittering, but should be good enough. Should be. Yeah. Okay, so that's how that would work, but let's save this in a good position where, at least here, let's go and take that part out. So velocity, I'm just going to mute that for the time being, save the file, and then run it again. Look at that, is beautiful, just seeing everything all tangled up and seeing the physics are working. That's what I like to see, just the physics are working beautifully. And there's no pinning happening either, so this is just it floating. Besides friction and all that. And these aren't sticking to the surface, besides there because of friction. But they won't stick there. Actually very mesmerizing just seeing the like ripple effect through the entire thing. Because right now there is no dampening in the system. It's just working. Just going around, all the velocities are just doing their thing. So they're just being averaged over time. And yeah, I should connect the iterations to the output there so that we can see that. With the length iterations, if we do, what the... Why did that cause... Okay. Oh, that's why, okay. Because of the initial explosion, if there's not too many, like, length steps, which just says, hey, stay within the correct distance of your neighbors and all that, the explosion just acts a little weird. Which, actually, let's crank that up. How different is it? Because the less this is, the more elasticity the rope will have. Which, ideally, when you have just chains, you want there to be absolutely no length difference whatsoever. Absolutely none. Yep. Look at that. That is beautiful. And I still want to make it so that, there is segment collision, so I won't need there to be a particle every single step, but... You know, I think this is fine for now. Okay. Do any of you have ideas of what to do next? Because I think... This is just mesmerizing. I keep saving it because I'm like, this is the good stuff. Let's make sure that this doesn't go away. So force direction, no, that's fine either way. Finally feels like I have a system that just works in most scenarios. Which before was like, oh no, self-collisions don't work good. And then, oh no, friction doesn't work good. And then, oh no, the length doesn't work good. But now I have all those together, and it's working very, very, very well. which I wonder if, is this better than what you can do in Blender by default? Because I know that some of the soft body stuff you can make kind of worms like this, but I wonder if it's this variable. Because again, the goal of simulation nodes and geometry nodes is to, like, look at that. Get that. The goal of geometry nodes, according to the devs, is to replace all the modifiers in all the physics systems. So I'm just trying to be a bit ahead of the curve, and also to upgrade my knowledge of physics, because someone asked before and I forgot to read the comment. Have you used Houdini? Yes, I have, in my work and personally a bit. But I find geometry nodes just more convenient because it's just in Blender. Because in my work, I often need to use geometry nodes in order to just, oh, edit this mesh, or hey, we need this visual. And because it's inside Blender, it's much more convenient, because with some projects that I work on and some commissions I worked on, the people who are on the receiving end of the commissions use Blender as well. So if I make a tool, it's much better for them. If I were to use Houdini, which, don't get me wrong, Houdini will always be better than Blender at procedural stuff. The program was built for it. Blender is very much trying to make itself procedural because there's a lot of old code that was not made for this. Yesterday's music was better. You must have joined late because we already ran through that soundtrack. So, yeah. It's the same songs, just we're listening to the second one in the list because we ran out of time. But yeah, someone in my Twitter comments yesterday was talking about the Houdini versus Blender thing and saying, like, Houdini's better, you should learn Houdini instead. Which, Houdini is better. It will always be better than Blender. But geometry nodes is more convenient for Blender projects because it's inside of Blender. And very useful in that regard. Because if I wanted to do this rope sim in Houdini, it would be, okay, I need to take my environment, export it as an alembic or a GLB, depending if it's moving or not, import it into Houdini, put up the sim with the objects that you need to do all that, export the sim as an alembic or something else, import it into Blender, make sure you have the cache and all that, and it all works. Like, that's a process, which if you're in professional environments, that's the usual thing. If you're working on, say, shows or movies or anything like that, that's how you would do it. Which that is why Houdini is industry standard with all that stuff. But if you have to iterate fast, and if your project is just inside of Blender and you want to keep it inside of Blender without the hassle of doing all that, geometry nodes is useful. And I should also mention, simulations are very... I would not recommend trying to do simulations inside of Blender. Do them inside of a program that's made to do it, like Houdini. But I see a future where Blender may be able to do simulations like that, and there will be simulation packs and stuff like that. I'm just trying to be ahead of the curve while getting them into Blender. One day. But, yeah. If you're looking to get into a professional environment while doing stuff like this, use Houdini. It is better. It has a steeper learning curve than geometry nodes because, well, geometry nodes is pretty gosh darn convenient, especially with attributes. You just go, boom, boom, you're good. And even with repeat zones, like, even though the iteration index is a little bit weird in Houdini, it's a little bit funky as well. But, yeah. I would recommend starting out with geometry nodes just to get a feel for the data. Or, actually... If you're already thinking about trying out geometry nodes, you can start without it. It's much lower stakes. You know, you don't have to get the indie license for Houdini, and also, you know, eventually you will have to pay for the Houdini license, which, you know, fair enough. I wish... Do they still have a perpetual license? I forgot. But anyway, geometry nodes are lower stakes, so, and I would probably say easier to learn. In terms of like the lower level stuff, like simulations are much easier to do in Houdini because, one, you know, they made it convenient. But this is rather lower level stuff than having a rope simulation node or something like that. I'm working my way up to that level. So it's a trade-off. It is a trade-off. Okay. What do I do next? Because, like with the bending, I still want to make it so that the rope will try to strain itself out over time. The problem is that I've tried that, and it didn't turn out too well. Like right now, it's just trying to keep a distance between the two. But if I take the two, what if I took the two positions and just tried to, well, actually, no. I want to make it so that it's more straightened out instead of the other thing, which I could just use that and mix that, plug that into Allies, and see that'll work. Let's try this out. So if I shoot, I was afraid of that. That's the problem that I keep running into. It's just like, oh, we're traveling. We're just moving. Any reason in particular? I don't know. Like, it is trying to straighten out, but it's just zooming away. Which, if I did it for both, which I did save this, so we should be in a good place at the moment. Let's just connect to these two. So, if we did that, and then I copy this, swap those parts, and then put that into there, we should see that looks like it's trying to straighten out, but it's acting very... Whoa. Why are you moving over there, buddy? And if I crank it up... Something just doesn't feel... What the... Oh, is it because this is inverted when it should be the other way around? That could possibly be a thing. Okay. Now this is becoming a mess in 0.3 seconds. Anyway. Let's move this over to here. Let's move this over to there. And I think this will work. Wrong one. 3, 2, 1. Let's see what happens. Oh, wait a second. Oh, nope, that's even worse. Okay. Just going to undo that really quickly. So that goes there, and that one goes down here. So yeah, that's something I need to figure out. That has to do with local space, kind of, not quite transformations, but something somewhat like that. And I just haven't figured that out yet. Or no, wait, I know what's happening. The endpoint, since it doesn't have a valid version of that, it's freaking out. So, okay, it's not working as intended because of stuff and things. Stuff and things. So let's just do that. So here... Actually, wait, I can do this a bit different. I'll use the switch node, set it to be a float, so that if it's the endpoint, none of that will happen because it has absolutely nowhere to go. So there, it should be working normally, and then as I increase this, it should try to straighten itself out a bit better. But if you go too far, it starts to freak out. So it looks like this is it's trying. It looks like it's trying. Yep. Or wait a minute. I just forgot. I could just make it so that it needs to have a force along its tangent. Like I blur the tangent and then just have that be a force. Maybe. I take the tangent, well, yeah, let's give this a go. So, UV tangent, no, not UV tangent. That's another node group that I made, and it's very useful. We should have that in default geometry nodes, but it's sad that we do not. Tangent, curve tangent, yes. So if I blur this by a bit, that might make it so that it wants to straighten out. Or, no, if I blur the position, but no, that's like how I did it before. But no, I can make it only affect that if the position and dot, no, yeah, no, that could work. I need to think about that. So if I take the tangent and the position, it's like, yeah, no, that could work. Tangent. So if I dot product this, those two, that'll happen. And then, okay. I'm cooking here. I think this would work. So if I set this up correctly, it'll add a force so that if the blurred position is like to the side, it'll try going to there. But if it's like here, it won't move over to there. Which in theory, if I'm correct, should make it so that it'll try to straighten out compared to everything else. So let's try it. So let's do that and that. There's a good chance that this will explode. So let's just try it out. Oh, I see that comment there. I'll take a look at it. Oh, wait. Looks like it's trying, but I'm not sure if it's... Multiply by 2? Or actually, yeah. Actually, wait. This makes it so that if it's straight, it will stay straight. But if it's bent, it will not be. That probably means I need to think about this for a little bit. I cross product the tangent by the blurred tangents. That will give me a normal vector. Or that will give me a vector that should straighten it out. So, no, I was kind of correct. Potentially. So if we have that and then cross product it, a cross product gives you basically the tangent rotated by 90 degrees, which will give us a normal, and then the normal should be possibly in the correct way. Then 0.1. So here we can see it's trying to bunch itself together. Or no, maybe it's spinning. So if it's spinning, maybe I just need to make it rotate again, potentially. Okay, well, that looks like it might be working. Like, that's freaking out, I think, because it's rotated the wrong way. It is trying to expand. Well, let's try something a lot less than that. And then maybe I can scale that by the dot product. Because right now, it's always having that kind of force. Like, the force is 1. There we go. There we can see it's sound waves. Kind of. Interesting. You can see it's at least trying to do something like that. So let's set it to be 1. So something like that, we can see that the waves are going through and it is trying to straighten out. Trying. Let's set it to be 10. Here we can see. It's really cool. Okay. It's really interesting. Now I want to think about what happens if I were to average the velocities. Because right now, if I recalculate the velocity and then blur it, what happens then? Okay. Well, that just makes it so that it's all shared. Rather than it acting as individual joints, it now acts like more of a whole. Here, if you do that, it acts like a thicker rope, which looks very, very interesting. It's not trying to straighten out or anything like that. So let me go and reintroduce that part. Whoa, okay, what's going on? Let's set that to be like 2. I'm amazed just at how stable it is. I'm not used to it being this stable. And then it just goes and flies away. I'm assuming because this tangent force is new... It's new data that's flying around. It's a new force, so conservation of energy is not happening there. But we can see there that it is trying to straighten out, at the very least. I know a dot product has to be used, but I am forgetting... Oh wait, no, if there's a dot product... Yeah, I'm really forgetting how to make that work. Well, maybe, no, if I connect this, it will absolutely 100% freak out, yep. So multiply, let's multiply it by 0.01, or 0.001, yeah. Because if it's aligned, it'll be a value of 1. If it's not aligned, then it'll be a value of... Yeah, so that should make it so that it's trying to twist a bit more. All that... Need to absolute it as well. So absolute, and then maybe map range to invert it. I'm not going to use a multiply add just for convenience sake for my puny little brain. There we can see, yeah, it's trying to straighten out. Physics, my dudes. Physics. Yeah. We're coming up on 2 hours, so I will call the stream here, but this was very productive. Much more productive than I thought it would be. I did not think I would get this stability in a sim like this anytime soon. Look at that. Like, it's actually knotted and it's actually working. Like, what is this? This is... I'm not used to my simulations being this good. Okay. So let's try one more time to think of ways of straightening it out. So, let's think. There is a... Let's think about this. The blurred position between these three would probably be around there. And that's like, oh, that's where I should go in order to straighten out. Which, yeah... But the problem is, if the average is over here... Yeah, no, that... Trying to move there. But the length constraints should make it so that it won't get any closer than it should be. In theory. We have that, and then... No, that... Feels like that should work. Does... But then, if it's off tilt, here, let's try it 1, let's set it to be 8. So let's try it out. Okay, that seems to be the wrong way because it seems to want to not. Oh, that's cool. But yeah, it's doing the exact opposite. Or actually, wait. Now, since it's the blurred position. Actually, wait, yeah. About that, because I made a system before with the blurred position that would want to swap that around and see what happens. Yeah, no, that's just trying to compress. Or no, it is straight. See, it is trying to straighten out. But it still feels like something's wrong. Like, if I do this and then make it so that... Yeah, no, it's straightening out. Oh, no, wait, but there still is that problem that we had before where, They're pulling against each other. So yeah, I could just make it so that yeah, they're just gaining velocity. I could just make it so that if it's on the endpoints, then nothing happens. So, oh god, yeah, spaghetti. Spaghetti happens when you're experimenting. There we go. So there, if we make it so that... Oh wait, no, the cache didn't reset. Interesting. What is happening? That's the weird thing. When you have a sim as good as this, like, it looks like it is trying to straighten out, but why the heck is it spinning like that? Why? I am confused and perplexed. Let's connect that into there, and then... Oh no, wait, that's the wrong one. Plug it into there. Yeah, I'm gonna clean this up. It's just like, come on here, let's go and let's tangle. But as we can see, it is trying to straighten out. That's more like it, okay. But it does seem like it... Yeah, that's why I was worried about. That's why I was worried about. The actual distance between them is getting longer. Like, it's getting there. I need to figure out, other stuff. Interesting. Yeah, both endpoints are having issues. Which I have a feeling, like, why... The question is, why would the endpoints have issues? Well, because they're not... They only have one part of the chain. Which means that in... Here, let's go and clean this up by a lot. By a lot. We don't need you, or we might need you, but... Yeah. Delete that, delete all that, delete all that. Keep you, put you here. Scale you. Okay. So, we have that issue before. Where... I could use the tangent to say, yeah, no, that could work. I could use the tangent and then say, this is ignoring the ends. I want to get the base functionality down first, and then I can bug fix later. So again, without any of that, we can see it's just normal. It should not be trying to straighten out because it should not be able to straighten out at all. That should be just the basic simulation, no fluff. If I scale that to 0, we get the exact same thing. Okay, let's Control Z a little bit. So we have that. With a step of 1, we can see that it's trying to do its thing, but we can see that there's a little bit more structure. 2, we can see more structure, and all that, but we get into the issue of, oh shoot, it's just getting bigger. So I need to make it so that if it aligns with the tangent, either positively or negatively, that it will scale it to 0. So let's use a map range. So if it aligns, we want it to have 0. If not, it'll be the normal amount. So here it should mean that when we turn this up more and more and more... Interesting. Not quite what I was expecting. Like, we can see here it is at least trying to straighten out quite a bit. Let's flip it around. Then that basically makes it so that it's all just expanding. How do we make it so that it's actually good? Oh wait, I forgot to normalize. That's why. Normalize. There we go. That was one of the reasons. So that should make it freak out because it's doing exact exactly what it shouldn't do. Let's try this out. Okay. It's trying to straighten out. It's trying to straighten out or double back to the point where it's not straight anymore. Interesting. Okay, we are past 2 hours now. Very fascinating. And we can see that it doesn't look like any new energy is heading into the system. How are the endpoints doing? The endpoints seem to be freaking out less. Still not great. Okay. Let's make it so that it'll be like the worst version of that, where I need to look this up, because I've done this before with I remember that I've done this before, but I forget what project. I know I need to use a dot product. Oop. Let's see, normalize before the blur? No, not in this case. Because the blur is a position. If I normalize the position, then that would just be a... Actually, no, that wouldn't work. That would be a position. So if I normalized it, it would think, oh, I'm just right in a circle around 0, 0, 0. If I normalize both of them, then potentially? But I kind of doubt it just with the way. Yeah, see, it's really trying to get back to home. Looks alive, and that's making me uncomfortable. Let's go and undo that. And we are out of music, which is the sign that we should be wrapping up the stream. Well, let me just rewind and start playing the regular music again. It'll be a little bit quieter because the music has different audio levels. Just because there's no standard. I'm still wondering why on earth this is the best method for like giving it stiffness. And why it makes it freak out, and why it makes the string just longer. Because actually, maybe... Or actually, yeah, no. Maybe I just need to feed that into the position, and then it does the, like, oh yeah, no, that could potentially work. Let's do that. Let's delete everything else so that we can call it a day. Okay, let's go over to here. I'm just going to replace the reference here with that and that. This might be really expensive, I'm not sure, with how it has to calculate. That is intriguing. Let's go and bump it up a bit more and see what happens. Okay, it is doing something. Oh god. Let's bump that down by a little bit. Okay, so if it's anything above 0.5, freaks out, which actually, that kind of makes sense. So, 0, as we can see, it's normal. 10, we're seeing a lot more rounded shapes. But I'm still not sure if that's actually good. Because yeah, I'm still not sure if that's actually good. Though on the bright side, we can see that the ends are no longer freaking out. So, success on that front. It could be used to make some alien creatures. Well, yeah. I have the little mimic effect from the Edge of Tomorrow movie that I've made several iterations of, and this is the next iteration. If I can get the strings to work as I intend. Like, right now we're doing the extra stuff, like, this is not needed for making a creature that's supposed to be very intimidating with all its vines flopping around and all that, but it would be good for me to make this more physically accurate. But anyway, okay, so we have a version that does work. And a version that does work is good enough for me. I'm also going to try turning off the endpoint part to see if it freaks out. Nope. Wow, it's actually good either way. Or is it? Is it? That endpoint going anywhere in a hurry? Nope, that seems to be fine to me, I think. Yep. Though that part does seem to be acting a little bit weird. So 0.5. No, do not go above 0.5. That gets exponentially worse. Yeah, I know it needs to use a dot product, but for the local space stuff, but I'll figure that out off stream. Look at that. It's trying to straighten out, but the knot is keeping it from doing so. What if I were to pin one of the ends again? Let's try that out. Nope, that was bad. Okay, so there seems to be a problem with if it goes too far, where it just starts to freak out. So I'll disable that for now, but keep it in my back pocket. And have all that. We add that to there. Yep, okay. But this is just the stiffness. Nope. F2, not F3. Interesting. So that is better. We have a version that is okay. Still it feels like I messed something up with the setup, because it doesn't seem as flowy as it was. Oh, that's because I'm blurring. Yeah, I'm blurring that. Which, oh, okay. I need to try that without blurring the velocity at all. Okay, let's disconnect that. Save it because it's in a good position. And then let's just go and donk, donk. Here we go. Of course. So the shared velocity was hiding a multitude of sins. Good to know. That part still kind of works. Kind of works. Actually, if I'm remembering correctly, well, it's just a question of what is the tangent, because the tangent only flows one way. I can't exactly get the could get the tangent ahead and behind, and average those, and then think of that as like a force, but no, that doesn't seem quite right. This seems to be the best method. No, it can't be. Okay, I'll figure this out off stream, because, yeah, it has to use the tangents, because world space positions probably won't. Probably, it's not great. Look at that. A rope simulation that actually looks okay. Can blur the velocity, and then it'll, you know, be a bit more stable, feel a bit better. Because it is, you know, it makes sense that the velocity is shared along things in a chain. Yeah. As much as I wish that I could just eliminate velocity from all of this and then just use positions, because, again, it's simpler, this isn't half bad. Like, the only thing I need to implement is proper delta time. That is compatible with substeps, because that just makes everything easier. And that's simple to do. I just need to make sure that I do it right, or else this thing will explode once more. Okay. Thank you all for watching this little exploration with physics and stuff. I hope the audio levels were good. I hope that the raycast mouse position thing was understandable. Cool stuff is coming to geometry nodes. And it's my goal to try to make some of those cool additions. Potentially. But yes, thank you all for watching, and I will see you next time. Have a good one.